Well, good afternoon, everybody, or good morning, depending on where you're joining us from. My name is Michael Woodhams. I'm from the Australian Institute of Architects based in Sydney. Let's begin by acknowledging the traditional owners of the land on which we produce this presentation, the Ngunnawal peoples, which is in New South Wales, as well as the traditional owners of the land from which you are viewing the presentation. Pay our respects to their elders past and present and recognise their culture as the longest living in the world. Welcome to this very important feedback session jointly hosted by the Australian Institute of Architects and the Australian Glass and Window Association. The Institute of Architects represents over 14,000 members globally and is committed to demonstrating the value of architecture to the public while simultaneously strengthening the profession and practice. The Australian Glass and Window Association represents over 1,200 organisations and provides accreditation services to ensure consumers receive best quality products and services. Today we have a distinguished panel of speakers from both organisations, as well as some representatives from the Australian Building Codes Board and our representative from Hassell on the ABCB Commercial Energy Efficiency Group. Now, if you haven't already taken the chance to submit something on the Google Forms, there's the QR code to get you cracking. Now, behind the scenes is my colleague, Ruth Nordstrom, who is a climate and energy expert, and she's in Adelaide helping us out. So Ruth will jump in and sort things out if I muck everything up. But why don't we get cracking and welcome James Whitehouse, who is with the Australian Glass and Window Association, who's going to introduce that organisation's involvement and their interest. And James, over to you. There's the QR code again.
Thank you very much. By all means, leave the QR code on if you wish for it. I'm going to say whilst people are having a look.
Sure.
Thank you very much, obviously, to the ABCB for putting this forward, the AIA for hosting us today. It's hopefully going to be very educational and hopefully everybody will get something from it. From our point of view, we've been involved with consultations around the NCC for numerous years, and we've been working very closely on this particular iteration. We've seen a lot of the proposed changes, and we think they're very fascinating, and we're looking forward to this session being able to present them out to the wider audience. I'm not going to go any further than that. Everybody who knows who we are and can reach out to us if they have technical queries or anything like that. So please, next person. Short but sweet.
Thank you. Thank you, James. That was very short and sweet. Well, I'd like to welcome Alison, if you'd like to go next. Alison's from Hassell and is the Institute's ABCB Commercial Energy Efficiency representative, and will provide a quick overview of the changes relevant to architects, I imagine.
Great. Thank you so much. So hopefully everyone will be able to see this in full screen. Okay, that's that for everyone. Great, excellent. So thanks for the introduction. Yeah, so I'm principal at Hassell Architecture, but I have pretty broad experience across a lot of different sectors, and I'm really passionate about environmentally responsive regenerative design, which has really driven my interest in joining the AIA National Climate Action and Sustainability Committee, but also being involved in a number of other sort of policies, design review panels across Australia, and then into the technical working group, advising into the commercial energy efficiency for 2025. So for those who don't know, the Climate Action Sustainability Committee actually does a number of different things across all of working with sort of the national committee, but also working into each of the states' committee chapters. And I think really we're keen that there is a very quick transition into improving our built environment. So we're looking to support 100% clean, renewable, clean energy futures, and a quick transition of the sector to 100% renewables. We're also looking at identifying ways that, that our members in the Architecture Committee can promote through their projects circular economy, supply chains and business practices And really key to our position and our role is how we work and collaborate with the industry stakeholders, including the ABCB and other members across the whole built environment industry. So just wanted to sort of touch a little bit on how we work. So we have working groups that sit within our committee. So we have a group that is focused on advocacy. So again, that's how we're pushing as much as we can within our practice experience to really, I guess, become leaders within the built environment around climate action. I'm really celebrating what we see as great sustainable outcomes. Through practice, helping our members and architectural practice implement sustainability into their practices and into their projects. And really work into how we educate and provide research into new fields. So that is around engaging with academics within the universities and being able to apply that research back into frameworks and tools that might support our members. So I won't go through these too much, but I guess it is about engagement, and it's about being active across areas. And obviously NCC is such a fundamental tool for architects to push and employ environmental practice in our design. That we really want to make sure that our members understand this, and that it is about how they understand NCC in tandem with many, many other tools and frameworks that sit out there within the built environment. And again, you know, working in with continued professional development within our members, particularly with regards to carbon and energy efficiency. And there is some endorsed carbon targets that we've set as an institute. So really it's key for us to engage very clearly with NCC 2025. Yes, we've been really trying to focus on how we review and champion changes throughout NCC as it progresses, looking to really focus on a reduction of emissions in the built environment and really enabling us to collectively move towards a net zero future. So the National Council targets really set and position for a nationally consistent methodology for embodied emissions and reporting into state and territory legislation by 2025, the elimination of the use of natural gas in all new buildings from 2025. And we acknowledge that this current update has a clear supporting mechanism for transitioning towards electrification. By 2030, we want to see all new buildings to have net zero operations, major renovations to have net zero operations, and really striving for a 40% reduction in embodied carbon. So these are quite bold goals that have been endorsed. By 2040, we really want to see all buildings having that net zero operational carbon emissions, and that we have retrofitting of existing buildings as well for clean energy. So just lastly, we do have a number of webinars that we are putting out to our members as well. So we've got one coming up around improving electrification through design, another one around practice of the future. So what does that look like? What does this transition look like for architects in September 2024? And then towards the end of the year, we've got an embodied carbon focus session. How do we get to this these high levels of reduction quickly? So I'll park it there. Thank you, everyone.
Thank you, Alison. That was very good. Erica, are you ready to, Erica or Mike or both or something combined? Are you ready to go?
Yep, absolutely. We're a bit of a double actor, so I'll lead and throw to Erica as needed. Okay,
so you guys are from the from ABCB, and I mean, I can introduce you if you like. Erica works in the policy and analysis team and is an energy efficiency specialist with over 20 years experience. Mike, you're an assistant manager at ABCB. I understand for the past 5 years you've been working on energy efficiency regulations for commercial and residential buildings. Is that correct?
Correct, yes.
Sounds great. Why don't you kick off?
Thank you. Okay, so would you like me to share? I'll share my screen. I think we'll have, you'll see exactly the same thing. And let me know when that comes up. Looking good? All right. Great. Thank you.
We've got your whole computer, yeah.
Yep. Okay. I'll just launch the slideshow so
Right.
it looks a bit more difficult, and I'll minimize myself so I don't get distracted by my hair, among other things. So thanks very much for hosting us today. A big thanks to Ruth, especially at the Australian Institute of Architects, who helped drive this, and also James at the Australian Glazing and Windows Association for having us here today. We are in the middle of public comment on the next edition of the National Construction Code, and today's session is going to be a deep dive for members of both organisations on the changes we're proposing to Part J of the National Construction Code. I have been here for a number of years. I'm one of the main staff members, along with Erica, who've been working on the changes, but it's building on work for over a number of years that we've been doing. I thank you, Michael, for your acknowledgement of country. I'm also coming to you today from Ngunnawal country. It's beautiful country. One of the things I was really surprised about when I moved to Canberra about 7 or 8 years ago was actually how beautiful this land is, and I really find it an inspiring place to live, even at this time of year when it's frosty and cold. And it just reminded that we have a duty of care to look after this land. And I'd like to pay my respects to Aboriginal elders past, present and emerging, and particularly any who may be on this call. Okay, so go through now onto what we're going to cover today. As I said, it's a bit of a deep dive. I'll be focusing in quite a bit on the changes to building envelopes with assistance from Erica, but I'll also cover some of the other key changes, some of the ones that you may have already seen relating to air conditioning equipment, the overall performance requirements, and especially changes to do with electric vehicles, solar panels, photovoltaic solar panels, and electrification readiness. And I'll also give you some information about how you can become involved in making comments, but I'll probably throw back to yourself, Michael, or to the teams there about consolidated Australian Institute of Architect and AGWA submissions to the public comment process. Okay. So I'll start with an overview, and I'll begin with some of the things that are kind of, this is a slide what I won't be covering today almost, but essentially there are some other changes that I just wanted to mention in relation to changes to the National Construction Code. So we'll be focusing on energy efficiency today, but we're also proposing to make changes in the areas of fire safety, waterproofing, condensation, female sanitary facilities, and in regards to the governing requirements and the way that standards are referenced. The public comment draft website, which is www.abcb.gov.au/PCD, has all of these changes along with a number of consultant reports, impact analysis work underpinning the changes and so forth. So if you're interested in finding out more about other aspects that are changing, then please have a look at the website. We can talk to some of those today if there's an interest, but noting that neither Erica and I may be able to answer those questions, may not be able to answer those questions. We may have to take things on notice. But there are other presentations which are going on around generally these changes that you will be able to get access to, including some in the next couple of days. But just noting that if adopted, these changes would become part of a revised National Construction Code, which sets the minimum standards for buildings. In other words, the changes would be raising the bar for the worst buildings you can legally build in Australia. So it's important stuff. Okay. Okay, this slide I put up and covers the why and the what at the highest level. And the objectives cover the reasons why we regulate minimum standards for energy efficiency through the National Construction Code. We want these buildings to be energy efficient to reduce greenhouse gas emissions and cost less to run. And we also want these buildings to be more resilient to a changing climate. And given one of the ways that we regulate energy consumption, especially for air conditioning systems, is to improve the quality of building envelope so that the resistance to thermal transference or heat flow from one inside to outside or from outside to inside, there is a real resilience effect that we are looking for, which means it protects building occupants and it also assists with the process of decarbonising the energy grid. I guess the fewer electrons of demand that we're adding to the grid by making our buildings more energy efficient, or these buildings coming online, potentially producing some of their own power, the overall task of decarbonising the electricity grid or energy grid as it stands for all existing buildings is made that little bit easier with every efficient building that we can add to it, especially if it's replacing an inefficient building. This also covers the outputs, which is an update to the minimum standards for energy efficiency in the National Construction Code. That's the what, and also part of the why here today is that it's government policy. Governments of both stripes, or many stripes over the last few years, have indicated that the National Construction Code is one of the mechanisms that we're going to reach our net zero and decarbonisation goals. It's explicitly called out in the Trajectory for Low Energy Buildings policy, but really all states and territories have net zero goals. We're also in this iteration of the code responding to propose the policy of the National Electric Vehicle Strategy, which is looking to get us to an electrified vehicle fleet as part of that 2050 goal. Okay, I'm going to move into the methodology of how we came up with these proposals, and I guess the way that we've come up with these new proposals that hopefully some of you had a chance to see, which I'll go into more detail in. Okay, so this is the parameters, the scope of what we're talking about in terms of commercial buildings, class 3 and 5 to 9 buildings, and the common areas of class 2 buildings. So that's apartment buildings, common areas, not the apartment building sole occupancy units or the apartments themselves, hotels, hostels, offices, schools, essentially all classes of buildings other than residential. The process that we followed was essentially a large energy modelling exercise where we took buildings that complied with the provisions as they currently stand, but were also reflective of common building designs. And we looked at how we could improve the energy efficiency of those buildings in the key areas that we regulate through the National Construction Code. We did that across all 8 climate zones. Essentially, we began with a cost-benefit exercise, or how far can we increase the efficiency of a building while it's still cost-effective. So that's the process. The individual DTS interventions were modelled at a building level. We also looked, as we were doing this cost-benefit analysis, to make sure that we didn't push so far, even if it was cost-effective, and ended up with only one supplier able to meet the requirements in the NCC. We also had to make sure that what we were proposing in terms of the buildings would be buildable, that you could actually produce a building that was able to meet the requirements. And of course, we had to make sure you produced a building that met the other requirements of the National Construction Code, whether it be looking at impacts to do with condensation, fire safety, and structural reliability and the like. So that produced a set of draft deemed to satisfy provisions. We then modelled them at the whole of building level across those different archetypes to see if there's further refinement that we could make. As we sort of traded between the different aspects of it. We consulted with our various committees, including the technical reference group on those findings, and we used that input to then further refine the provisions to what ended up in the National Construction Code public comment draft currently available. There is a few things in this model which I wanted to highlight as well about how we did the modelling, and it may give you a steer to how we, why we maybe produce some of the results that we found. So in terms of when you're doing this process, in terms of your energy models, there are a few things that you need to assume. One is the cost of energy, one is the cost of carbon, and one is what the weather is going to be doing. And you also need to consider what the costs are for the equipment that you're sourcing, whether it be windows or whether it be air conditioning equipment. So in terms of energy price, we used a national average energy price and a national average feed-in tariff. That was a single cents per kilowatt hour or cents per megajoule figure across the entire country. We didn't choose for variations between time of use or for states and territories. We used a price of carbon which is akin to the US EPA's, sorry, United States Environmental Protection Agency's social cost of carbon, which is around $200 per tonne of carbon that for every abated or prevented tonne of carbon going to the atmosphere. We valued that at $200. And we also used the CSIRO's future weather file of an RCP 8.5 2050. So this is work that's done by the CSIRO. It's a typical mean year file, similar to those which are used in the NATA's software tool, but have also been available for tools like Energy Plus, which was the software that was used in this modelling. And it predicts what the weather is going to be doing on an average basis in 2050. So they're I think the key modelling assumptions that we made. In terms of the building archetypes, you can see there's an Energy Plus design there. There are 11 archetypes we use to develop the measures based on common building designs, which we also assessed with the technical reference group. So we did a small and a large office, a small and a large hospital, a small and a large retail, so a big box retail and a strip retail, a large hotel, a small hotel or a motel, a classroom, and I think an intermediate size office altogether. I'm not sure if that's up to 11, but it's across the board. They're the archetypes we used. I guess the most difficult one to model is something like a 9B community centre. We used a school for that, but there are many different types of 9B buildings in terms of community centres. There's many different types of hotels, there's many different types of hostels and the like, but more modelling is always good, but we were limited in time and scope, and believe that the amount of modelling we did gave us enough to be able to produce a defensible set of proposals here. Okay, while we were doing it in terms of methodology, we investigated 3 distinct sets of stringency. So we investigated, I guess, as option 1, a minimum cost effective, taking into account those things around buildability and unintended consequences across the code. So essentially looking at a 2022 code, how far can you push that while maintaining cost effectiveness? We then took those measures and we added renewable energy systems, on-site PV essentially is the most cost effective, to see what that looked like in terms of a set of provisions. And then again, that was done as a cost benefit analysis. How much cost effective PV can you add to a building? And finally, we looked at a least cost pathway to net zero ready buildings. So this wasn't a cost benefit analysis. It was what can we do to get these buildings to net zero through the national control as a minimum pathway. We took those options and ran them through a regulation impact assessment. And off the back of that, it was the decision of building ministers and the board that we go to public comment on the net zero ready option. So what you'll see in the code is a net zero ready option for new commercial buildings. Oh. Apologies, it seems my slides have frozen. Give them a sec. Oh yeah, here we go. Great. Hopefully it won't skip forward. So high level, and this is what we'll go into in more detail going forward in the rest of the presentation. What are we looking at for new commercial buildings? So for building envelopes, we're looking at increased solar heat gain stringency for facades in terms of facade solar admittance. So it's not necessarily glass, that's the entire facade being more sensitive to solar admittance, some refined building ceiling provisions, and the reduced ability to trade performance within a given facade between different stories. For heating, ventilation, and air conditioning, we're looking at increased stringency for chillers and treating chillers in a more holistic manner than we had done previously, seeing how they work within directly related to a building's load, cooling load. Looking at mandatory variable speed operation for pumps and fans in a majority of spaces. And we're looking at making sure that that building, if they choose to be dual fuel, is able to electrify in the future. In terms of building modelling, in terms of the JV3 pathways, we've made some significant changes there. One is requiring the use of a future weather file that RCP 8.5 2050 scenario that I mentioned before when you're doing a JV3 pathway. We're ending the PV offset as we look to make PV mandatory. So we're not going to give you a free kick for installing PV in terms of your building envelope. And we've introduced a requirement that your building combined facade and services, so your proposed building must be 10% better than your reference building. So that brings JV3 or J1V3 in line with neighbours and Green Star in terms of a model pathway. As just mentioned, we're looking at mandatory on-site solar PV panels for all new commercial buildings and mandatory on-site electric vehicle charging in buildings with more than 40 car parking spaces. Actually, in all commercial buildings, actually, there'll be mandatory on EV requirement. And we're retaining the existing requirements for Class 2 apartment buildings to be ready to rough in and EV charging in the future. And we're extending that roughing in requirement to electric vehicles. So these are the big ticket, high headline changes that we're talking about in the NCC for 2025. I'm going to jump in and go into more detail. But first, I think I got a slide on. So I mentioned regulation impact assessment. The regulation impact assessment is a mandatory approach that all governments must take when they're introducing new regulations to look at the overall benefits. They're relatively substantial with what we're proposing for NCC 2025. So 16.8 billion. But that in terms of the lifetime of the regulation, note the EV charging provisions are a net cost in terms of the mandatory requirement for electric vehicle chargers to come in. This is partly because we have the roughing in requirements already introduced, and those roughing in requirements are already a benefit that we've claimed from previous years, and they're one of the main benefits in terms of the EV requirements. But there's also, as you can see, the substantial electricity savings and substantial greenhouse gas emission savings as well. All right, I'm going to jump into the key changes now. How am I going for time? So at 12:30. We're going through to 1:30 today, I understand. So hopefully I'll get through the rest of the presentation before 1 p.m. And so we've got at least half an hour for questions, but I'll keep an eye on time and skip through if I need to. Okay, so I'm going to focus in on the key changes for building fabric. Okay, so for building envelopes, I mentioned before there's going to be a reduced facade solar admittance requirement, which is an increase in the performance of the facade as it relates to cooling loads within a building. The focus is on reducing cooling loads. This extends the emphasis that began to shift in NCC 2019. Commercial buildings, for the most part, are cooling dominated across all climate zones, especially if they operate during the 9 to 5 times. And so driving down cooling is a key part of cooling loads is a key part of making buildings more energy efficient. It also makes them more resilient, as I mentioned. I'll go into a bit more detail on all of these in just a sec. There's a change to the definition of building envelope, which is designed to reduce the need for internal installation where it's not necessary. We've added in vertical shading as a pathway to the deemed to satisfy elemental revisions, and we've reduced the ability to trade U values and solar heat gain coefficient values between stories within a building. So I'll jump into those a bit more now. Okay, so this is a screenshot looking at how maximum solar admittance changes have for daytime operating buildings, so class 2s, class 5s, 6, 7, 8, and 9Bs. So you see that it's become more uniform across the country in terms of the overall solar admittance across the different aspects. And it, depending on your climate zone, this may be a significant change in some cases and I guess less significant in others. One of the comments we got from 2019 was around, what we have these sort of uniform across the country solar admittance requirements, and it doesn't seem to be very responsive to the actual climate that you're in. And I guess the response to that was at the time and remains that as you increase energy efficiency, the ability to keep, well, one, keeping the sun out is important, especially for daytime operating buildings because of cooling loads. But as you get more energy efficient, it becomes more uniform across the entire country. And so as we, the DTS becomes blunter, the more stringent it becomes. There's still room for nuance within design, especially if you're following a verification method, and we still retain that ability to trade. Okay, so I mentioned before, at the moment, we're proposing a change to the definition of envelope. And this is a key thing that we found that the 2019 changes, or even before that, you're required to insulate between a conditioned and unconditioned space internally, even if the unconditioned space adjacent to the conditioned space had its temperature determined, by the building's by the building's air conditioning system, or wasn't really affected by external ambient conditions. This meant that we were requiring people to install insulation when where it wasn't necessary, wasn't having any effect, and they were also in some cases able to use that internal insulation to trade with the external insulation and reduce the external part of the facades. So we found that as we were, again, as we're making the building more efficient overall, it was important to only allow that trading when insulation was necessary within the building. So this is a screenshot from a case study that we're producing on this different topic. You can see in the past, potentially if those toilets up there were not considered as conditioned space, you would have to insulate between those, and you would no longer have to provide that insulation. Right, so, and I'll talk about those case studies and when they should become available, hopefully in the coming weeks. Okay, staying with facades, I mentioned we have introduced vertical shading as a deemed to satisfy. So presently, if you have a vertical shade on your building, you can claim it as a device if it meets the requirement as a shading device, but it doesn't give you necessarily the benefit that you might expect from a vertical shading projection. So this is DTS, and currently you'd have to do a performance solution, such as a JV3, to get the full benefit from your vertical shading. But introducing this as an option, we're hoping to encourage vertical shading, that especially on a western aspect or an eastern aspect could be very effective in stopping solar gain coming into a building. And finally, this idea of the decreased ability to trade within the building envelope. So currently, you can trade the total system U value of your facade between different stories. So between the first story and the 10th story, you could have a smaller amount of glazing on a lower story and a higher amount of glazing on an upper story. Now, if you were doing that within a JV3 or the neighbour's pathway, for example, within the code, you'd also have to make sure that that space met comfort requirements, such as using the predicted mean vote. From a deemed to satisfy pathway, there isn't that comfort requirement backup, which essentially is serving as an envelope protection to protect occupants. And so we're proposing to remove that ability to trade between different stories. You can still trade between different aspects on the same story, and you can still trade within a story between glazing. So you, in terms of meeting the overall requirement, so you can have within a story have more glazing in one section and less in another, as long as it meets the overall total system U value. But yes, between different stories. And I'm interested in your thoughts on this. It does limit design potentially. I guess the question is whether you feel it's a warranted change in terms of protection of the building occupants. Yes, and it's carried across both method 1 and method 2. So yeah, you can still trade between different aspects, but only within the same story, as proposed. Oh, I forgot solar reflective index. So presently, we use solar absorbance as the mechanism which controls, I guess, roof color. And it was set to be 0.45 in NCC 2019, which is essentially a light colored roof. So it's the NCC has had a light colored roof policy as a deemed to satisfy pathway for commercial buildings for a number of years now. We're introducing solar reflective index as an alternative pathway for roofs, in terms of it's effectively the same, it's the inverse of solar absorbance. We believe it's a more accurate measure. It also allows us to set a differential requirement where you have a metal roof which has air conditioning plant installed on the roof. So the metal roof with the microclimate that it creates around it, it's significant that enough for us to introduce the effect on the air conditioning performance is significant enough for us to introduce a requirement to have a higher solar reflective index in those scenarios. We've also made some minor changes through Part J5 to the building ceiling provisions. These are still remain qualitative in terms of application. The building envelope still needs to be sealed up, but there's some changes there in terms of wording to try and clarify when sealing is or isn't required. So there's I didn't want to go into a great deal of detail. These are qualitative changes trying to improve the clarity of the NCC. So they're changes for building envelopes. I'm just going to go through some of the other key changes in the time I have remaining, and then I'll hopefully open up to questions. So I mentioned the verification methods and the performance requirement have also undergone some changes. So J1P1 is the energy efficiency performance requirement for commercial buildings. This was quantified in 2019. It has a kilojoules of energy per square meter per hour of operation target that was introduced in 2019 to give you I guess a pure performance solution possibility within the NCC. These stringency have been so the stringency of these figures have been increased, and a carbon metric has been added to the performance requirement, and it reflects a near zero energy performance. It's not exactly at zero because we know that the grid will not be fully decarbonized for a number of years, and actually getting all building classifications to a net zero target is going to be difficult depending on the building form, its typology, its size, and so forth. But it does reflect a near net zero level of performance. We've updated the neighbours pathway to just J1V1 to reflect that. So there's a higher neighbours commitment agreement level of 6 stars that it varies between building types. Thank you, Erica. So that I think it's 6 stars for office buildings and lower for other building classifications. So class 3s, class 6s, and class 2 common areas can use the neighbours pathway presently. And I mentioned upfront the changes to the J1V3 pathway in terms of future climate, especially. The Green Star pathway remains unchanged, and the J1V4 pathway in terms of building ceiling verification using a blower door test remains unchanged. There is a small change to J1V5 verification using a reference building for class 2 buildings or class 2 apartment buildings, so occupancy units. We've extended the requirement to meet the cooling load to climate zone 6 and to meet the heating load cap in climate zones 2. So a slight expansion of the requirements in those climate zones. I touched high level on the air conditioning and electric ready requirements earlier on in terms of the key headline changes. There's a new metric for chillers we're proposing to introduce called a climate specific part load value that is designed. The main intent of this change is to make chiller selection more fit for purpose, both in terms of the technology that you use and the load and the sizing of that equipment. So it's trying to drive you towards good design as best as we can through the National Construction Code. Fans and pumps will require variable speed operation. It's incredibly cost effective in most cases to introduce variable speed operation. And so that you'll see that as a requirement. There's other changes for HVAC equipment to do with how controls are specified, and some changes to do with economy cycles in terms of when they are going to be required going forward. But perhaps one of the biggest changes overall, not just for air conditioning equipment, that it relates to future electrification. If a building is dual fuel in terms of using gas for its space heating or heated water, either for sanitary or for sanitary domestic purposes, domestic hot water use, or for hydronic heating, or for heating of pool and spa pump water, it will be required to make it easier or more straightforward for that building to replace that gas equipment with electric equipment in the future. That means that the building needs to have physical space in terms of where that equipment will go. It needs to have electrical capacity space in terms of its supply from the grid. It needs to have switchboard space so that that equipment can be plugged into the building's main switchboard or its various distribution boards. And specifically for the heated hot water loop, it means it needs to have its hot water loops designed to able to be used 50-degree Celsius water, which is well, not the optimum, but it's a temperature that works well with heat pump technology. So there's a number of things that your building must do if it uses gas upfront to make sure that it can electrify in the future. Okay, another key change that I'm going to go through, electric vehicles and on-site renewables. I'll start with the PV provisions. So high level, we're proposing that all new commercial buildings, unless they're heavily shaded or have other exemptions, install solar PV if they're following the deemed to satisfy pathway, and all buildings have electric vehicle charging. I guess that's the headline, as I mentioned before. So what does that look like? So that requirement is built into the performance requirement. So in terms of J1P1, as I mentioned before, it's a net target. So it will be inclusive of on-site PV. So those quite tight greenhouse gas emission and kilojoules per square meter targets can be done inclusive of on-site PV. So we're looking at a building which is net zero, both in terms of carbon of its energy sources and energy use, producing and using as much energy on site as it's drawing from the grid. And also J1P1 has the readiness requirement if PV is not installed, but it is clarified that if you do install PV, you don't need to make your building PV ready going forward. So in J95, which is currently about readiness for PV, we've put in 2 new pathways around on-site solar PV. The first is a peak system output of watts per square meter of conditioned space. So if you have a small amount of conditioned space in your building, then you'll need a small amount of solar, or you have to install PV across the available roof space. And I'll go through what available means in just a sec. If as part of the electrification or dual fuel requirements, if gas is installed on site, these amounts are higher to better offset the use of gas, which is more difficult to offset in terms of its carbon emissions than electrical equipment, both because the grid is decarbonising and 2, because you have to export that energy in a greater extent than the energy is being used on site in terms of doing the netting out of it. Okay, so available excludes quite a lot of things. Areas shaded for more than 10% of daylight hours, a greater 45-degree pitch if you use the roof for terrace or roof gardens, car park, skylight or the like, area that's used for plant and equipment, and I believe reserved for plant and equipment in the future, above exhaust airflows, heat rejection equipment, or simply where it's deemed to be impractical for other reasons, too close to the edge, or a space needs to be trafficable and those type of things. So if you have a small amount of roof space, the amount of solar will be quite low as well. So headline solar is required, but maybe subheading maybe not as much as you might think. In terms of the requirement for EV charging, it's in J9D4. It's requirements for type 2 7 kilowatt chargers. If you have more than 40 car parking spaces in car parks or car parking areas, that would need to be in 10% of spaces. So say you've got a building which has 100 car parking spaces in a class 5 office, 10 of those would need to have EV chargers installed. It's higher in a class 3, 7B, 8 or 9 building. And also 10% of your car parks which are required to be accessible must also have an electric vehicle charger. If you have 40 or fewer car parking spaces, the code actually says less. We have arguments in here about what the right thing to say is. We all understand the meaning. 40 or less car parking spaces, you must install at least one one charger to your building. So that's the EV requirements. As I said, it's type 2. There's also a quantified performance requirement for electric vehicle charging, which is that your electric vehicle charging meets 20% of the daily driving needs of the building occupants. So if you don't want to do 7 kilowatt chargers, maybe you've got a retail precinct and you want to do faster charging, as long as you can show that you're meeting that 20% of daily driving needs as it's predicted to be, you can do that instead of following the deemed to satisfy as a performance solution. Some other charges about where you place your changes focusing on where you place your distribution boards. Or if you don't want to use distribution boards but want to use bus duct, you can do that instead. As I mentioned, you still have to make class 2 apartment buildings ready for electric vehicle, and 100% of car parking spaces, that's unchanged. And the requirement for a charge control system, which is a really important requirement to make sure that EV charging is scheduled and responds to building energy use, it remains in place. Okay, so pause there for questions around. I'll stop sharing my screen. And I'm not sure how we've been going in the chat. So they came to a rather abrupt halt. I can see there's maybe some questions in the chat, or where would we like to begin? I'll throw back to you, Michael.
Oh yeah, thanks, Mike. That was really good. We've had a few questions come through on the verification performance section. So if I just read one out, it's got a lot of the coding and all the the letters and numbers in there, but you'll know what I'm talking about. Let's go for the first one. J1V1, neighbours energy ref J4D6. Can you explain if the maximum U value of 5.8 for glazing, including display glazing, is per floor elevation or maximum for a single window?
It's maximum for a single window. So this is a really good question, and it's one that came up last week. So essentially, we're putting a backstop in your total U value calculations for your facade. So you can trade between across, well, more limited than it used to be, but the trading element in terms of the total system U value now has a backstop of 5.8 in it. So you cannot have glazing in there, which is greater than that.
All right. Let's try another one here. This is quite a long one. Again, this is related to J1V3. Verification using a reference. Achieving 10% better than a reference building seems difficult to achieve technically. Does it even meet the ABCB's own stated rules for performance solutions, i.e. shouldn't it be just the same as or better than the DTS measures? This is the comment. I fear this will disincentivize the pursuit of J1V3 performance solutions. Yep.
Okay. That's this is why we do public comment. So that's there's a I guess there's a understand where the opinion is coming from, and it's definitely would encourage that to be included as part of public comment so we can evaluate it. So the reason we brought in this proposed change I guess there's a couple of reasons behind it. One is that it sort of aligns the J1V3 method with the Green Star and Neighbours pathways. So Green Star pathway, you have to be 10% or better than that. So that's already built. That's hard boiled into Green Star as a pathway. Also within Neighbours, there is, I guess, through the design review process, the Neighbours pathway, when you're doing your Neighbours commitment agreements, you usually factor in a degree of performance better. You put some fat in there. So JV3 was sort of out of step with those two other performance pathways. Would point out that this 10% is where you do a JV3 for both your building facade and services. So it's not just the building facade needs to be 10% better. If you're doing a facade only JV3, which is the majority of JV3 use pathways, then it's just, a kilogram better than a kilogram of CO2 better than the reference building, because we went to our technical committee and were told 10% better on the facade only basis was way too hard and would be impossible to meet. So, but we think that with the minimum performance of services included in that, so we're then making sure that your air conditioning, your lighting, overall, that the 10% is achievable. And what this is doing, yes, it is making the JV3 more stringent as a pathway, but it's guarding against, I guess, potential errors in the modelling. All models are wrong. Some models are useful, as they say, and I guess the approach is to make your modelling more robust and produce better buildings, and it also works against, we think, gaming, either intentional or unintentional, of the J1B3 pathway. Performance solutions will still be possible. Comparison to the DTS as a pathway will still be possible as a pathway, as a performance solution. Please follow the governing requirements in terms of the development of performance solution, but if you can still do a version of, I guess, comparison to the DTS as a performance solution, will still be there as an option, just making that a little bit more difficult.
Thanks, Mike. Okay, still on verification of performance. This one relates to J1P4, renewable energy and EV charging. With regard to clause J9D5, points 2 and 3, it notes 100% of the roof is to be solar, barring certain areas. But if a dual fuel building, it must have further on-site PV. Where would these be located on a CBD style building?
Hello, Michael. If you want, I'll have a go at answering that one.
Great.
I guess we haven't specified where it would go on any building. That will be up to the design team to solve that question. In terms of the development of the measure, what was assumed was that in most cases, what was assumed in the costing was that it would be ground-mounted PV. Obviously, that may not be possible for every building, depending on the footprint of the building and the footprint of the site. So I guess in that case, I would suggest people have a look at their other options of how to show compliance under the code. And I suppose to be completely frank, it may be easier in that case to not specify the building as a dual fuel building, in which case you would not have to put in the additional PV.
All right.
Facade, sorry, James just threw in the chat, facade PV, building integrated photovoltaic panels would be an option. Have to make sure that they comply with the rest of the NCC, especially in related to waterproofing and fire safety. But yes, integrated facade PV panels would be another option for sure.
All right, thank you, Mike and Erica. Can we move on to some DTS questions now? You happy with that? Okay, so this relates to J4D6 building fabric, wall glazing. If cooling is dominant in most climates in 9 to 5 buildings, what's the rationale for lowering the solar admittance for overnight use categories? The added passive heating in winter would surely provide more benefit than the increased cooling during summer in climate zone 7 and even CZ6.
Sure. I think Erica's going to jump in and take that one.
Yeah,
so.
look, I'll just have the first go. I'm sure Mike might be thinking of something that he can add. I guess this comes from the modelling. So as I said, we had a comprehensive modelling process where we tested the measures across 11 different archetypes and across all 8 climate zones. So that's essentially the output from that process. We did test, when we were developing the measures, we did look at both overnight operating buildings and overnight operating buildings and daytime operating buildings. That was for the initial measures development. I think we just chose a sample of each building type, and then when bringing the measures together, we tested across all 11 archetypes to see how the buildings would perform compared with the NCC 22 baseline, and then that's what fed into the impact analysis. I also wanted to say, for the first time, well, at least I don't think this happened in NCC 19, but we have published the technical reports from that development process. So on our public comment draft website, which is abcb.gov.au/PCD, you can download a copy of so there's a specific report covering off on envelopes. So you can see what the process was and details of all the archetypes that were used there. So Mike, I don't know if you got something to add to that.
So we do see an increase in winter heating from these requirements. So that is reflected in the report. So the overall energy use is lower in these buildings, but the heating does go up because they're getting less solar gain from these requirements. This is driven by the use of a future climate file, I think, to an extent. So we're looking at this RCP of 2050 8.5. So this is a much warmer climate than we're in currently. And the DTS reflects that, and the greenhouse, the J1V3 pathway reflects that. We think that it's, well, one, we're responding to the policy, the trajectory for low energy buildings policy, which used this same climate scenario. It is responding to, it's only to an extent with buildings, especially fully air-conditioned buildings. HVAC designers are already building in equipment, or that the equipment does deal with quite extreme days already, so that the impact on air conditioning equipment maybe isn't as strong as it is on facades. But again, this is a key question to explore through the public comment, that we've developed these provisions based on RCP 2.5. Have we gone too far in that regard, going into the future? But so please, we encourage that as a comment coming through to let us know what you think about the use of RCP 8.5.
All right, thank you. Let's have a look at J4D6, building fabric. Wall glazing construction. What's the reason for the very high wall R values for climate zone 1? They're comparable to climate zone 8, but the annual temperature differential between indoor and outdoor temperatures is generally much lower in climate zone 1. Climate zone 1 should be higher than climate zone 2, but the improvement on climate zone 2 requirements would surely have a significant impact to the cost benefit assessment in climate zone 1.
So I might start with this one, and Erica. So again, this will be in the technical report that sort of justifies that level. This, I think, is justified on the basis of keeping the cooling in, as opposed to keeping the heat out. So these are models of fully air conditioning buildings that we're running here, and I guess the thing to keep in mind is if you have a naturally ventilated building in the tropics, then the envelope provisions, if your building is able to naturally ventilate itself, then the envelope provisions wouldn't apply. It's only conditioned space that we're talking about. So if you have a conditioned space in the tropics, then I guess the role that the insulation is playing in keeping that cool in is what's driving this result. It will come down to looking at our models. Have we made the right assumptions? Looking through the technical reports, looking at whether or not we've made the right decisions in terms of the building design. There may be a specific building archetype that is driving this specific result. So yeah, given the rationale behind it, but in terms of why this particular result is being driven, it will come down to the results of our energy models directly.
I just wanted
Okay.
to add to
Yeah, go for
that.
it.
It sounds like the person who asked that question's already had a really good look at the draft code, so thank you for that. But just in case not everybody on the call has, just wanted to kind of clarify that that R value requirement that was being asked about is only I think the questioner was asking about the case where the wall is 80% or more opaque. If there's so that's only where there's 20% or less glazing. So if the wall has a higher glazing proportion, which I guess many walls in many buildings would have, then there's a different requirement. So I just wanted to clarify that. That's all.
Yeah. Okay. Well, we might come back to that, Erica. Let's look at J2D2 if we can. Energy efficiency application. Any activity on minimum performance factors for existing buildings?
So the code, as it's called up in the state and territory legislations, applies to new work. So if there is work being done on an existing building, then the local certifying authority may choose to require that building to be brought up to the existing standard. It depends on the volume and change of work, but the code does not apply retrospectively. In general, it doesn't, unless you are doing that work and seeking development approval from your local certifying authority, this won't come into play on a mandatory basis. It may drive work on a voluntary basis, where people look at the requirements setting for the new NCC and decide that they want to bring their building up to that standard, but there's no trigger within the NCC to require existing buildings to meet this standard.
All right. Now I've got a general question here. I think this is still, Ruth, this is still coming from the Google forms, and then we're going to grab a couple of, I'll go to a couple of comments from the chat in Zoom. If we're assuming an all-electric future, why are we referring to building energy consumption in megajoules as opposed to kilowatt hours per sum annually?
I'll have a go at that one, Michael. So in terms of what the code assumes, we were specifically in our policy authority, we were asked to be fuel neutral. So that is we're accommodating both gas and electric in the DTS pathway. In terms of the performance requirement, possibly that's what, I'm not quite sure if that's what the question's asking about, but in the performance requirement, there is a requirement there that's in terms of kilowatt hours per meter squared per hour per year. Oh, kilojoules, sorry, Mike's telling me, per meter squared per hour per year, as well as a emissions type figure. I guess in order to convert between kilojoules and kilowatt hours, it's a fairly straightforward, like they're both measures of energy, so that can be done. I don't know, the question you also sort of, in terms of the chat, what I can see there is about kilowatts per hour, which is something different. That's in terms of demand, and we do have some consideration of demand in terms of overall how the measures have been set. The idea in terms of, in general, how we're considering electrical demand is that we're trying to design the code to support, I guess, to support the transition of the energy grid, including demand management, and that's kind of built into the EV measures, and it's actually been built into the design of the PV measure as well. So I'm not 100% sure if I've answered the question, because it sort of seems to cover quite a few areas, but hopefully I've managed to at least touch on it there.
All right. Well, we can get that chat going in the side here anyway. We've just got comments. We can follow that through. Now let's have a look at something that has come through directly from the chat. If we're moving to an expectation of greater EVs, can the ventilation requirements for basements be reduced accordingly? Mechanical ventilation in basements is a large cost. An offset is a good sell point. Okay, does that make sense?
Yep, and
Okay.
I will call Erica in on this because she's been working quite closely with the standards committee on 1668 Part 2, which is the standard that the code refers to in terms of ventilation requirements. And so that is something that's part of the consideration. So the way we regulate ventilation of car parks is by referring to the Australian standard, and it's currently under review. And a part of the consideration is that as you move towards less carbon monoxide and other tailpipe emissions, because we have more EVs, already have 10% of sales of vehicles being EVs, and more EVs are coming into our car parks and on our streets, then yes, the car park ventilation for air quality will be relaxed over time. But I believe that the committee have not reached the final decision yet. So it'll be, once that has landed, you'd be able to see what the impact will be at this point. But yeah, it's on our radar. It's on the committee's radar for 1668.
Okay, now in relation to that still, however, there's a comment here, however, the cost to ventilate or smoke relief may offset this significantly as a result of toxic gases emitted during a potential car park fire.
Yeah, well, as Mike said, that is a matter that's been considered by the AS 1668 committee, which is ME 062 Australian Standards Committee. So they have published a draft update of AS 1668 Part 2. That's the one that deals with general ventilation. There's a separate standard, AS 1668 Part 1, that deals specifically with smoke and fire. And I believe that they're looking at considering a project to update that, but that's in its really early stages. So just in terms of in general how those standards are structured though, the general ventilation requirements of AS 1668 Part 2 and Part 4 are separate than the smoke and fire. And the look, I'm not a fire engineer, but from talking to fire engineers, I do understand that the kind of volumes of air that we're talking about in regards to smoke and fire are really different and much bigger than the volumes of air that we're talking about in regards to general ventilation. So I think that's worth bearing in mind. And the other thing to note is that the published public comment, so Australian Standards Australia had its own public comment draft on AS 1668 Part 2. So that was published, I don't know, a couple of months ago. I don't know the exact timing, maybe February or March this year, on the proposed update to AS 1668 Part 2. The thing that was driving that update was the fact that the standard hadn't been updated since 2012, and there's been like quite big changes, not even thinking about EVs at all, and certainly not thinking about any sort of issues relating to what would happen if there was a fire in a car park where EVs were parked, but just in terms of general operation of vehicles and the exhaust emissions that they produce in regular operation, because that standard is about regular ventilation. There's been sort of big changes. Vehicles that are around now produce a lot less tailpipe emissions than the average fleet did in 2012 or before that.
Okay, and there's a comment in relating to insurance premiums for body corporates relating to EVs and potential fires over the next decade. Have you got anything to say about that?
We had a project at the NCC which looked at fire safety for modern vehicles, and that's led to some changes to the fire safety requirements for car parks with over 40 car park spaces. It includes the removal of the existing concession for open deck car parks to not have sprinkler systems. And so if you have an open deck car park, it now has more than 40 spaces, you have to have sprinklers in place, and there are also removal of concessions for the for lower FRLs. So how long something needs to be able to burn for before it collapses. So as I said, I used the word modern vehicles before. Modern vehicles, in comparison to when we did this research initially back in the 1980s, have got a lot more plastic. They're wider. Car park fires, whether they're EVs or not, whether there's an EV charger in there or not, will be different. And we believe that we're taking a balanced approach to the the differential risk posed by modern vehicles as opposed to the risk that was posed by when the provisions were put forward. The NCC, so we think that we've struck the right balance. Again, there is a chance to put public comment on. We tried to take an evidence-based approach. Believe that the risk the risk is probably, in terms of a fire happening in a car park, is, we believe, not much changed as it was previously. There is a differential risk with an EV fire as opposed to a internal combustion engine fire, but the likelihood of an EV spontaneously combusting or catching fire while charging is shown to be really very low. And so that's why we think that the approach we're changing is balanced. Again, public comments open. Let us know if you think we've got the right approach there. Decisions made by insurers off the back of that, I wouldn't want to speak to the integrity and honesty of an organisation or a group of insurers. I'm sure that they're acting on their own, on an evidence basis, opposed to their own best interests. But maybe you could move on.
Okay, thanks, Mike. We've got about 10 or 15 minutes remaining, so if you've got a comment or a question to go in, we'll be able to save all of this as well, so that'll be quite useful. But we've got a couple of others here that I'm just looking through that might be quite interesting for you. Does the extent of solar panels excluded because of heritage listed buildings where the where the impact on heritage is significant? Does the extent of solar panels exclude does that make sense?
Yeah, I think
I'm just trying to reword that off the cuff.
There's no specific consideration in the DTS provisions about heritage buildings. So there is a number of specific exclusions that are mentioned, and Mike went through most of them, and it's talking about, for example, roofs where they're shaded, or where there's a roof garden or skylight, where the roof is used as a trafficable area, or where it's impractical on account of panel size or mounting system limitations. So there's no specific exclusion for a heritage. Maybe some of those things will be triggered or be more likely to be triggered on more of the roof area in a heritage building. It would really be a matter for a building code consultant and a decision to provide advice, and a matter for the certifier, building certifier or building surveyor, to make a decision on there. But yeah, in terms of the DTS, no consideration about heritage in the DTS.
Right.
Yep. So just to say, if the local certifying authority has a planning scheme which prohibits solar panels in certain areas, I think that would probably take precedence over that it's their job to show that building or how that building complies with the National Construction Code. And I think the exemption there for impractical might be what you would look at. But again, as Erica said, that's a question for the local certifier.
Okay, let's keep going in the chat here. More information on PV built into facades, please.
Well, I'm not an expert on building integrated PV. The thing to keep in mind is that there are combustible materials inside the solar panels themselves, and so how you make sure that they are fire isolated is one of the key considerations if you're using that, designing a building with those, as well as the waterproofing requirements. They're not a mandatory part of the DTS. They could form part of a performance solution. They could form part of a DTS solution in terms of that additional PV requirement that we talked about before. I'm trying to think if I can think of a good report on BIPV, building integrated PV, off the top of my head, but yeah. I guess we could throw back the question, and what would you like to know about?
All right, let's perhaps if you can pop that in the chat for Mike and Erica, and we can get back to you in a bit more detail there. Let's have a look at, this is a question going back to DTS, J2 D2 energy efficiency application. Any activity on minimum performance factors for existing buildings?
No, that's it. It's the same as the question before on existing buildings. It's
Yeah,
not something we can cover. It's outside the scope of the NCC.
right. And this one is in the chats. It's a fairly recent one here. J1V1 verification. Neighbours Energy Ref D J4D6. As much as display glazing is allowed, RBEW 5.8, does this greatly constrain any addition glazing on that particular building level, considering the rest of the facade would have a much lower UW value?
So short answer is no, because you exclude the display glazing from the envelope consideration. So if you look at the definition of envelope, it says don't count display glazing. So your total U value has to be for the envelope, and you treat display glazing separately.
All right, there's a general question here. Now it was a little wordy, and Ruth's kindly rejigged it for me. Why are we assuming we need AC in all buildings? Space heating and cooling for all buildings. This is not just a zone 1 or tropical issue, it's an issue in temperate climates also.
Yep. So the code doesn't require you to have heating and cooling. As I said before, the provisions around envelope and air conditioning kick in when you have a space that is conditioned or likely to need conditioning. If you design a space that doesn't need conditioning and it's not completely naturally ventilated, then the Part J4, Part J5, Part J6 requirements of the code wouldn't apply, because they apply to envelopes around conditioned spaces. So there is a pathway for naturally ventilated buildings coming through the NCC, absolutely.
All right. Ruth, have you got anything to add from your standpoint? Have you got any questions you'd like to chuck in there?
I've just sent you a couple in your chat there.
Yeah.
To that. Let's have a look here.
I have jumped around a little bit here. I'm trying not to repeat anything or overdo
this is an ongoing question from all across institute members about when are we going to see more inclusion for the circular economy principles, such as waste and embodied carbon, and maybe in the future that might play into different energy sources and biofuels and things. Are we going to see that maybe in the future of NCC, or what direction is are these current measures taking us in?
Embodied carbon is part of the future, as far as I'm concerned, and I think it's definitely on the ABCB radar. We've been part of the conversations with neighbours and MECLA around the development of the methodology for measuring embodied carbon in buildings. I think the next step will be mandatory disclosure of embodied carbon at buildings, and indeed New South Wales government planning schemes have already got something along those lines for residential buildings. We're looking at how it can be done. At the moment, the code looks at operational emissions, or operational energy use and operational greenhouse gas emissions. That's still, if you look at the building life cycle, the biggest part of a building's greenhouse impact is from its operational use. That will change and will drop quickly as the grid decarbonizes. And so capturing the greenhouse emissions from the building embodied emissions in material selection is going to be really, really important. And I think there will be a role for the NCC in regulating that. The question is, what is an acceptable minimum standard? I think we need to do the research and data about, for Australian buildings, what is our current embodied carbon impact across the range of building types that we regulate through the NCC, and where is a room to, what's the signal we want to send in terms of embodied carbon within buildings. And when we do that, I think we'll be able to better include the benefit of maintaining existing building fabric through renovations, and so people are encouraged to maintain more of a building and not will reuse as much as they can. There's still some further work that needs to be done on getting the methodology out there. Neighbours, I think, they're consulting right now on their methodology. That's one. There's already neighbours for energy within the NCC. In terms of specific waste from building sites, how you set your embodied carbon metric, if that was inclusive of all materials that were sent to a site, that may be something that could encourage lower waste within buildings, within building sites in terms of construction. Yeah, it's on our radar. It's part of our conversation. There's nothing in the public comment draft that you'll see which speaks specifically to embodied carbon. But it is something that we want to, I personally would like to see in the NCC going forward.
I just wanted to jump in because there was an aspect of that question that was about biofuels, I think, got mentioned. Just in terms of what we have in the DTS at the moment for energy efficiency, so just going back to talking about operational energy as opposed to embodied carbon, in terms of the DTS, we're really just trying to accommodate, I guess, the most common solutions. Like DTS is kind of like the lowest common denominator. So if somebody wants to construct a building that uses biofuels for its operational energy services, then certainly that can happen under the NCC, but that would likely need to follow a performance solution in order to show compliance with the performance requirement. And the performance requirements expressed in general terms, it certainly doesn't specify, it specifies energy, and it's like J1P1 talks about energy intensity and emissions intensity, but it doesn't mention any kind of fuel types at all. So you could use any fuel type you like for a performance solution.
All right, thank you both. Why don't we we'll finish things up with a quick look at question 8 from the survey. Now, if I do this correctly, there we go. Can everybody see that?
Yes.
Can everybody see that little screenshot we've done?
Yes,
People
that's
can give
Okay.
a thumbs up if they need to, but yep.
Yep. Okay, that sounds good. So who'd like to have a comment on that from the speakers?
Looks like we need to do more about lifetime emissions and indoor health based on the survey that we've got from you. I guess I don't know. I don't want to sound defensive. I know this is going to sound defensive. We work to a policy authority. So we work within the policy authority that we've been set. And in terms of what we've been asked to do, it was through the trajectory to low energy buildings, the national electric vehicle strategy, and the net zero targets. And I realise net zero must go beyond operational energy. But in terms of what we were asked to do for this round, the focus is still operational energy. Obviously, like as we just sort of got to in the previous answer, that may need to change in future, and certainly sounds like it's interesting to hear from your members' point of view. It looks like it really needs to change based on what your members are saying.
Okay, thanks, Erica. James, do you have anything to add to that graph? No, that little chart or bar chart there.
No, I think I'd agree with Erica as far as where we are with the policies dictates what can and can't be put forward. I think we'd all like to see more down the line, but we're guided with where we start.
Okay, Alison, I might give the final word to you if you like.
Oh, thank you. Yeah, look, I mean, I think Erica sort of touched on it earlier, where there's a sort of a minimum, and then there's what we can aspire to do in our project work. So I know that's something that we're doing within the Institute, which is actually really being able to have more discussion and really try and get alignment between, you know, I guess where there's sort of more ambitious opportunities within the market and what the NCC mandates. So just encourage everyone to kind of keep advocating, I think.
All right. Thanks very much, Alison.
Thank you.
Yeah, right. Thank you very much. Well, we've just clocked over 1:30, so that's excellent timing. We had 114 people on the call today. Now that includes, I think that was 114, barring the 4 or 5 of us involved in the presentation. Ruth, is there anything else we need to add before we wrap it up?
No, I think that's it. I'd just like to say thanks to the ABCB for also facilitating with Agua and obviously the Institute, because combined it means that we get a broader scope of questions. And also in terms of putting in submissions, the survey will still be open for a little bit so that you can contribute that way as well.
And just before we wrap up, I just wanted to mention one more thing. We're publishing some case studies in collaboration with Department of Climate Change, Energy, the Environment and Water, probably in about a week or so. So they'll cover off on PV, EV charging, electrification and building envelope changes with a kind of illustration of how the provisions could be applied if they do get adopted. So Ruth, I'll probably reach out to you when that gets published,
absolutely.
because we think that will be of great interest to your members.
Yep. Thank you very much. Yep.
Indeed it will. Thank you, Erica. Thank you, Mike. Thank you, James. Thank you, Alison. Thank you, Ruth, for helping me with putting this, portraying this morning. The feedback that you all give is very important for all of us, and it's a great contribution from everybody. And before we wrap up, I'll just remind you that we're doing a similar session on waterproofing and water shedding scheduled for the 16th of June. So stay tuned for the comms on that. If that's all, thank you everyone, and have a very good afternoon. Bye-bye.